Okay, so I'm going to go through question 8 from exercise 13D for you because a few people said they struggled with part C and D. So I'm just going to write down some of the key info. We've got a submarine at 0.54. I'm going to actually try and do a little diagram. So -5, I've got submarine P, and it fires a torpedo with velocity vector 3 - 1. Okay, so that means it's got a direction. If we're imagining I'm writing down the direction vector of the torpedo starts from -5, and it travels, and I'll show you what I'm writing in a second, but I'm just looking at this to start with now. Travels with a velocity of 3 - 1. So I'm going to add that to my diagram. So this torpedo is kind of traveling in that direction. That is at T is in minutes, and that starts at 1:34. Submarine Q is at 15:7, and it fires a torpedo with velocity vector -4, sorry, -4, -3. I keep missing off my minuses. Okay, so that is going in another direction. Now, this question would be a lot easier if these torpedoes were fired at the same time, but submarine Q has a delay. It fires it later. Okay, so that is going to impact how we write down our vector equations. Okay, all right, I'm just going to switch to the other camera now so you can see what I've written down. Let me go to here. Okay, so I've got my submarine P, and this kind of represents where the torpedo is going, and then my submarine Q, and this represents where the torpedo is going. I'm not sure how accurate this is, if it goes this side of the origin or the other. Those axes are just to give me some sort of basis of where to start my diagram. Okay, I think the hardest bit about this question is knowing what to write here, because if we wrote just T, then after 1 minute it would be like this torpedo had already moved by this once. Okay, but this is actually A minutes later. I'm going to imagine that A is a number just to help me get my head around this. So let's say that A was 5. So this torpedo goes, and then 5 minutes later, this torpedo goes. At the exact moment of 5 minutes, this torpedo is still just in its starting position. So when T is 5, I don't want this to have had any impact. I want this to kind of be 0. So in order to get that, what I need to put here is T minus A. So whatever time it is, so I'm still imagining that A is 5. So say it's 5 minutes later, I would do 5 minus 5, so that this becomes 0 and this is the starting point. If it was 6 minutes later, I want for torpedo P to be this starting point plus 6 lots of this movement, and I'd want this to be at this point and 1 lot of that movement. So I'm still imagining that A is 5, but I'm looking 6 minutes after this starting time. So I personally think that knowing to write T minus A here is the hardest part of this. Okay, so it's saying however many minutes have passed, there were 5 minutes or A minutes when this torpedo was going nowhere. So we have to subtract that. Okay, so A isn't 5, it's just A. It would probably be a lot easier if it was an actual value. So getting to this point, I think, is the hardest bit. All right, so moving on, I just need to go back and look at the question again. Show that the position vectors of torpedo P can be written like this. Okay, I've essentially done that, right? I've written my vector equation. So part A, if I just take the different components, I've got the x1, if I let r of p be x1 and y1, and r of q be x2 and y2, then using the same notation as in the question, then I just get x1 is minus 5 plus 3t. I'm taking this top component, and that y1 is 4 minus t. Okay, then for part B, I'm doing the same thing. I'm taking the x component, so it's 15 minus 4 lots of t minus a, and y2 is 7 minus 3 lots of t minus a. All right, so part B, oh sorry, that's part C. Okay, that's part C, and that is the part that some people said they were having problems with. So unless you can figure out and justify it in your own head why we have to put t minus a here, so it's whatever time it is with 5 minutes or 6 minutes or whatever it is taken off because there's a delay. If you can get your head around that, then part C is obvious. Sorry, this is actually part C. Okay, part B was asking for the speed of torpedo P, and so you just find the modulus of that. So the speed is given by the square root of 3 squared plus 1 squared. So it's the square root of 10. All right. Then it says, part D, Q's torpedo is successful in knocking out P's torpedo. Okay, so this, the first one fires, and I don't know, I guess there's something over here that it's going to hit, and this submarine is trying to defend this target, and so it tries to shoot out the torpedo mid-air, and brilliant, it's successful at that. So we know that these two paths cross. The question is, do they cross at the same time? So to do part D, we kind of assume that the paths do cross, and we try to find T. So the paths do cross at the same time, and we try to find T. The question says it is successful, so we know we're going to be able to find the time. The question could easily have said, does torpedo Q take out torpedo P? And if it had said that, we'd assume that it did and find T. And if it actually didn't cross, then we'd get an inconsistent answer. We might get that T equals 7, but also T equals 5, and that would be contradictory. Okay, so we'd get 5 equals 7, which we know isn't true. So if we end up with a contradiction, then we know we don't have a solution. So what we do here, and again, going back to these original vector equations, if you know how these are formed, then the rest of the question really just kind of falls into place. We'd say here we need the x component of the first torpedo at some given time to equal the x component of the second torpedo, and we also need the y component to equal the y component, like that. So we have simultaneous equations here. We've got two equations, we've got two unknowns, t and a. So you'd need to solve these algebraically to find t and a. Let's call that equation 1, let's call that equation 2. So first let's simplify them. So I'm going to say I've got my 3t and add on 4t, so I've got 7t equals 20 plus 4a, and here I've got minus t plus 3t, I'll have 2t equals 3 plus 3a. All right, how do we solve these? I'll probably multiply this one by 3 and this one by 4 to get 12a in both equations, and then I can subtract. So 21t, 60 plus 12a, and 8t is 12 plus 12a, and then I'll subtract. So I'll get 13t equals 48, which is really not a very nice answer. T is 48 over 13 minutes. So remember that T is in minutes. So, oh, that really isn't a very nice answer. I suppose I feel like at this moment, when I've got that, I want to check that. I want to check the answer really. Just double check that I've done this right. Times 4 times 4. Okay, I can't spot a mistake yet, but you might be watching this and thinking that you can spot one. Okay, so T is, well, I've got 13, 26, 39. So that would be 3 minutes and 9/13 of a minute, which would be 3 minutes. And I'd have to, I'm going to definitely use my calculator on this one. I want to do 9/13 of a minute. To convert that into seconds, I do times 60. Oh dear, this really isn't looking good. So that's 41.5. So I'm going to call that 42 seconds to the nearest second. All right, the question doesn't just ask us when, it also, I don't think it just asks us when, I think it also asks us at what time did Q fire its torpedo. So we also need to find A. It doesn't ask us where they meet, which is a small mercy. So A, let's use our simultaneous equations to find A. So we know that 2t is 3 plus 3a. I'll use this one. A is going to be 2 times t minus 3 over 3. So I'll go back to using the unrounded version of time. So I'll have 2 times 48 over 13. Take away 3 and divide by 3. So 19/13. Again, I'm not really feeling this answer. I feel like this is just not a round enough answer. Actually, I'm going to pause here and go and check it out. Okay, I've just gone and checked the answers, and good news, this is correct, almost. The only thing that I haven't done is actually now converted this into the actual time of day. So you might remember right back at the beginning of the question, we were told that this whole process kicks off at 1:34. So this is basically when t is 0. So I found that t is, for the first question, t is 3 minutes and 42 seconds. So that translates to an actual time of day that that this torpedo smashed the other torpedo, right? This is the time they actually met, is 1:34 plus this. So this is 1:37 and 42 seconds. And this is of the torpedo crash. And similarly for this other one, the time delay that Q, or the time that Q fired, was 1 minute and 28 seconds after 1:34. So that is 1:35 and 28 seconds. Okay, and just to prove it, here are the answers. There we go. Torpedo is fired at 1:38 and 1:35:28 p.m. Forgot to put p.m. And the explosion occurs at 1:37:42 p.m. There we go.